I'm pleased to introduce the speaker for this session, David Lecomber. David is Senior Director for HPC at ARM and responsible for HPC business at ARM, helping partners go to market and working with the HPC market to understand its future needs and help it adopt ARM technology. It will now be our pleasure to hear from David Lecomber.
Hello, it's my pleasure to be here today at bigcompute to talk to you about advancing HPC in the cloud on ARM. Firstly, I'd like to introduce ARM. ARM is the world's leading semiconductor intellectual property supplier. We've got more than 600 silicon partners, and those partners combine ARM IP with their own IP to create complete chip designs. So our technologies are providing products from the smallest sensors to most of the world's smartphones and some of the world's most powerful supercomputers. In fact, since ARM's inception in 1990, over 230 billion chips have been shipped using ARM technology. And the pace of those shipments is increasing. Last year alone, over 29 billion chips shipped with ARM technology. Together with ARM's partners, we're at the forefront of designing, securing, and managing all areas of connected compute, from the chip to the cloud. And it's the cloud that brings me here today to bigcompute. Because with rescale support of ARM-based servers from an increasing number of cloud vendors, access to the cloud using ARM-based servers has never been easier. You can today find ARM-based servers at every major hyperscaler, many private cloud providers, and of course directly from OEM server vendors too. ARM Neoverse is the range of it's the IP portfolio for the server and infrastructure market which ARM produces. And whilst this is directly deployed within those clouds, for many reasons the hyperscalers will obtain, there are many benefits from developing and deploying Neoverse servers. Those benefits also translate to you as users of the cloud. So let me just go through what those benefits are. The value proposition of ARM Neoverse-based computing is pretty simple. It can help you to increase application performance on a broad set of workloads, vCPU to vCPU. Neoverse chips are outperforming the latest CPUs, x86 CPUs from Intel and AMD. It can help you to reduce cost. So Neoverse-based instances are priced lower for the same amount of computing resource compared to x86-based instances. And finally, it can boost the sustainability and reduce the carbon footprint of your work in the cloud. ARM Neoverse-based CPUs consume less power per vCPU compared to x86-based instances. So taken individually, these are three distinct benefits, but typically they combine to offer an even greater incentive to try ARM. AWS was the first cloud provider to offer ARM Neoverse-based instances, and they're now on their third generation of offerings based on AWS Graviton 3. The majority of AWS instances are based on AWS Graviton 2 today, which became available in 2019. And since that time, AWS's full spectrum of vCPUs supports Graviton 2s, including instances of workloads that are general purpose, compute optimized, memory optimized, storage optimized, or supporting, for example, accelerated computing. There's a C6G and a C6GN flavor, which adds the Amazon Elastic Fabric adapter, which gives 100 gigabits of network bandwidth and is targeted at HPC use cases. And more recently, AWS Graviton 3 was launched, and these are now generally available, the C7G family, which offers even better general purpose performance compared to Graviton 2 based instances, but even more higher performance for compute-bound and HPC workloads, and a 3x improvement in ML performance over the Graviton 2. There's a 2x performance increase in floating point performance, and they also have DDR5 memory. In fact, the first such servers with DDR5 in the AWS fleet, which gives you almost double the memory bandwidth per core. Graviton 3 also improves power efficiency consuming 60% less energy for the same task as Graviton2. And AWS have a very large and expanding number of customers, a customer base that are using Graviton2. You'll see many of the names that are familiar here. Amongst many of you today, I'm sure workloads from software vendors such as Ansys, Cadence, Synopsys, and others are really important to you. But you can see many, in addition to the software being provided, there are many companies who've adopted AWS Graviton as a way of reducing their cost of HPC and getting results faster. More recently, Microsoft Azure VMs based on Ampere Altra's ARM-based server CPU became available and generally available. There are a number of different instances within this fleet able to run general purpose Linux workloads, web servers, application servers, open source databases, and so forth. And another, the EPS v5 VM series that are designed to meet requirements for memory-intensive Linux-based workloads, for example, in-memory caching applications, open source databases, etc. In addition, these VMs also support many of Microsoft's major development platforms, .NET 5, .NET 6, and latest Visual Studio tools. Google's cloud has now introduced the Tau T2A VMs. These are also, like the Azure instances, based on the Ampere Altra CPU, with, in this case, support for up to 48 vCPUs per instance. As you can imagine, with Google, these instances come with Kubernetes GKE support right from the start, including a mixed support for ARM only, as well as the multi-architecture clusters that might have ARM and x86 architecture clusters. And GKE customers can make use of popular features like autopilot or GKE data plane v2 networking. In addition, Google's also introduced a robust ISV ecosystem around this product with leading tools for DevOps, such as security and observability like Datadog, Dynatrace, Splunk, and Palo Alto networks. Let's put some color on the benefits of price and performance. If you look at the spec int workload and the cost of running that across each of these hyperscalers and their ARM-based instances, the ARM instances are roughly half the cost to run that workload. But of course, benchmarks alone are not really why we consume cloud compute. We want to run workloads out there. Well, as it happens, ARM is actually a significant user of the cloud because we have all of the design work that we do for our IP that must be designed, verified, and consumes considerable amounts of compute time. And when we analysed the performance and the cost of running on ARM-based servers, we absolutely adopted these within our fleet. If you examine the EDA tool performance on the Graviton2s against the equivalent instances that you would need to use to do this on x86, then these charts are showing the relative performance improvement between the x86 instances and the Graviton instances. As you can see, it's above the line, above one for every one of those workloads. And so in addition to that performance improvement for everything that we do, there's also the cost improvement as well, as each of these vCPUs was actually cheaper to run as well. So it's a double benefit for us. Another really important workload today is ML, and ML inference in particular, where a lot of that workload is actually happening on CPU rather than on GPUs. When people want to mix their applying ML inference within an existing workload, it often doesn't make sense to run a GPU instance or an instance with specific accelerators added. You want to really run that on CPU. In fact, there's an awful lot of ML is run that way. And so what does ML inference look like when you're running in the cloud? Well, on the AWS fleet with the Graviton 3, there is now support for bfloat 16, and this has enabled us to provide a much improved performance over the previous generation of Graviton 2, but also a massive improvement versus their existing fleet of x86-based instances. As you can see here, for ResNet 50, And for BERT, those increases with C7G, AWS Graviton 3 that is, on the right, outperforming the C6i Intel Ice Lake platforms, as well as obviously AWS Graviton 2. Now you add to that the cost per vCPU has also come down, then again, massive performance benefit from a very simple move from adopting one platform and running exactly the same software or software packages on the other platform, seamlessly generating faster results at lower cost. If we turn to another field, seismic modeling, SPEC FEM3D running on AWS Graviton 3, a single socket of AWS Graviton 3 is competing exceptionally well versus two sockets of Intel Ice Lake and AMD Milan. And when you translate that into a cost perspective, there's a very clear advantage to running Graviton 3. And we see the same in other fields of costs. Fluid dynamics, I'm sure that's really important to a number of people here. Using the OpenFOAM package, we see, again, a single AWS Graviton 3 server, which is 64 vCPUs, is able to produce performance that is comparable to the two-socket AMD Milan with 96 cores and the 64-core but two-socket Intel Ice Lake servers. And from a cost perspective, again, even against the HPC 6A instances, it is cheaper to run that on ARM. And it's not just open source software that is now supporting ARM. An increasing number of software vendors are now recognizing that there's a really compelling reason that their customers are asking them, when are you going to be supporting ARM? And they are also seeing benefits when they migrate some of their software as a service offerings into supporting the ARM architecture too. Altair Radios is one good example of an ISV who's been supporting ARM for a number of years now, and also is supported through the Open Radios project as well. We've seen some really great scaling here when running on the Ampere Altra instances. Amongst other ISVs who are supporting ARM now, we find ANSYS Fluent, as well as ANSYS LS Dyna, and there are a number of others who are in progress at the moment with their ports and expecting to announce very soon. Looking forward to being able to talk about those at a future date. In summary, to conclude, ARM instances are now available at every leading cloud vendor, and I'm really excited that the Rescale platform is enabling you to easily access those instances. It's enabling you to get access to some competitive performance at a competitive cost and also a much greener footprint, which is something that matters to all of us. All of the major open source software you'll find in HPC and AI is running on ARM these days, and we're seeing an increasing number of ISVs, including some of the who are now supporting ARM, and also the very leading ones are already there, and others are on the way and imminent. So it's never been a better time to actually give this a try, see how it looks on your workloads, and thank you very much for listening. It's been a pleasure to talk to you today. Bye.